Lesson 1.8, projectiles at an angle. So this is the I do example, so you'll watch me do it. What are the initial horizontal and vertical velocities of a soccer ball after it has been kicked with an initial velocity of 12 meters per second and an angle of 30 degrees to the horizon? All right, so as you can see, this diagram is actually nicely drawn out for us. So here, the question is essentially saying, okay, like they give you, hold on, let me see. Oops. Oh, that's why you can't see it. Sorry. So they give you this line right here, right? And that represents our initial velocity. This is 12 meters per second. And they do give us theta, right? They say theta is equal to 30 degrees. So our job is, we have to think about, how am I going to break 12 meters per second up into components, right? So that horizontal and vertical velocity components. So if you remember that animation that I showed you in like two previous slides, there were specific formulas that we have to use. So the first one, what is the initial velocity? So, the horizontal initial velocity. So what we are going to have to use is this formula, Vix equals Vi cosine theta. And then for our vertical initial velocity, the formula that we'd have to use is VIY equals VI sine theta. So I'm going to add a page and, I'm going to do the guess method like we always do. Okay, so my givens, right? We have VI equals, not 9, oops. It equals 12 meters per second. Theta equals 30 degrees. Okay. The unknowns that we want to know is VI, or let me rewrite the order of the subscripts. VXI, we don't know what this is, and we don't know what VYI equals. We don't know what those are. So just like before, I spoke about the appropriate equations that you should be using. So here I will use pink to represent the VXI formula. So VXI, how do we solve for that? We would do VI cosine theta, okay? And then I will use this green color to indicate what are we going to be using for the vertical velocity. So we do VYI equals VI sine theta, okay? Now we do our substitution step. And again, I can't stress this enough, please do not forget the units. It is such a shame for you to lose points if you don't put units, so this is what we don't know, so we're going to leave this VXI equals 12 meters per second times cosine of 30. Okay, so we'll leave that there. We'll get our vertical velocity right now. So VYI equals 12 meters per second times sine of 30 degrees. Okay, also really big thing here. Your calculator has to be in degrees. So I'll just write this right on top. Calculator in degrees. Most of our calculators are already in degrees, but if your calculator is not in degrees, you'll end up with the wrong answer here. Okay, and that would be such a shame to happen. So always make sure that you're checking your calculator to make sure that the mode is in degrees. Okay, so now we do the last part, which is solve. So if you do VXI in your calculator, so I have my handy dandy calculator right here, and I say 12 times cosine 30, you should get an answer of, let's change the color again, you should get an answer VXI equals 10.4 meters per second. So I did round here. My calculator did give me 10.39, but I just rounded up to the 10th place, so I did 10.4 meters per second. Again, cannot stress the units enough. Please do not forget them. And then VYI, if I do 12 times sine of 30. I get 6 meters per second. Again, don't forget the units here. All right, so I cannot stress this enough. So if we go back to our lovely diagram, and I pull away these squares, you will see that my answers do match up with what we just did in terms of the math, okay? So I'll circle, I will circle these guys. That's your final answer. So now let's work on the we do example. So it says, base your answers to the following questions on the information below. An outfielder throws a baseball to the first baseman at a speed of 19.6 meters per second at an angle of 30 above the horizon. So essentially, in terms of a diagram, what you would see is, this ball, it is moving in a diagonal. And if you drew out like a dotted line that represented the horizon, we would say theta equals 30 degrees. And your initial velocity would be 19.6 meters per second. Okay, that represents VI. So here, they want to know which pair represents the initial horizontal velocity, Vx, and the initial vertical velocity, Vy, of that baseball. So just like before, we're going to use our handy-dandy formulas. So if we want to do the horizontal first, Vxi equals Vi cosine theta. So Vxi equals 19.6 meters per second. Cosine of 30. Vxi equals, so again, use your handy dandy calculator. Cannot stress it enough. Make sure that your calculator is in degree mode, okay? Because it would be such a shame to get it wrong. Okay, so we get an answer of 16.97. So roughly we can say that is 17 meters per second. And then for Vy, let me change the color. I'll do this light pink. So my Vy of I equals Vi. Oops, not cosine. We are in fact using sine theta. So Vyi equals 19.6 meters per second times sine, I don't know what's happening to my iPad, sine of 30. Let me erase these dots because they kind of look a little confusing. And you should get a solution of, let's see, do 19.6 sine 30. You should get Vyi equals 9.8 meters per second. Okay, so Vx is about 17. So any answer where we see that it's not 17 already, right? Vx, this is wrong, this is wrong, this is wrong. The only answer that makes sense is A, right? Because our Vy value is 19.6, and then 17 we got right here. Okay, so now you can try the you do example, and you're literally going to follow the same exact steps, and just don't get tricked. Think about, if my object is experiencing projectile motion, think about what happens to that horizontal component and think about what happens to the vertical component over time.